Hello, this is Mrs. Ringrose, and I wanted to make sure that we all know how to write equations to lines that are parallel or perpendicular to another line. So one of the things we learned is that parallel lines have the same slope, but different intercept. So maybe you're already good at these kind of questions, but they kind of all flow through, and you're going to use the same strategy. So for this one, we're going to highlight the word that tells us how to find the slope. I know that parallel lines have the same slope, so I'm going to keep the slope the same, but I know that it goes through this point. Now, we can either use point slope form to write the equation, or we can do y equals mx plus b and then solve. So whatever's been working for you so far is fine. I'm going to show both methods real quick. Y minus the y that I know equals my slope times x minus the x that I know. That's point slope form. And then I'm going to go ahead and multiply that through. 4 into 8 is 2. 2 times 3 is 6. Y equals that. And that's my equation. It has the same slope, but a different y-intercept. And I can confirm that it goes through that point because I can put these numbers in, and it's a true statement. Not 6, that should be 8. Because 8 times 3/4 is 6, and 6 plus 3 is 9. So that's one way. If you don't like using point slope form, that's okay. We can start with y equals mx plus b. It's our familiar, most important formula. And then I can plug everything in. 9 is my y. 3/4 is my m. 8 is my x. I multiply these together and I get 6. And then I minus this from both sides. And I get that b is equal to 3. And then I plug my information back into this. And there's my answer again. So either one works at doing it. So then there was another example to try. It's parallel. We're going to keep the same slope, but we probably know how to do that. Then there's questions where you don't know the slope. And this is a similar question to what will be on your test, because we want to make sure that you're prepared for SATs and stuff like that. So this equation is in standard form. So our strategy is to put this into slope intercept form. Once the slope is highlighted, then I can go ahead and do exactly what I just did above. So in order to turn this into slope intercept form, there's usually 2 steps. I'm going to move the x term. Sometimes it's written with the y first, so you just got to pay attention. You want to make sure you solve this for y equals. I subtracted x because the 6x was positive, and that's going to undo that operation. And then I'm going to bring down everything that I have. So when the 5y comes down, it comes down as negative because the negative is attached to that 5. And then I still don't have y equals. There's this negative 5 that I need to get rid of to isolate the y. So then usually the next step, if there's a number, is divide by the coefficient of y, right? Because we want to isolate y. And when you divide, you have to remember to divide all 3 things. Multiplication and division is distributive. So when we multiply through parentheses or divide, it's like there's parentheses on that whole right side of my equation. So that's why everything gets divided. This cancels. Now I have y is isolated. A negative over negative becomes positive. And then I know that negative 7 over 5 is ugly. It's a positive, decimal. We don't really care what it is because we only want to worry about the slope because the line is parallel. I mean, I don't have the directions there, but we're going with parallel still. So parallel to that line that goes through that. So now I know my slope is 6 over 5. And now I can go ahead and do whatever method I like from above. So I'm going to go with y equals mx plus b. And I'm going to plug in my point. So I got negative 9 for y, 6 over 5 for m, 15 for x. And I put 6 divided by 5 times 15 in the calculator, and I get 18, I think. And then that's a positive 18 because both those numbers are positive, so I'm going to subtract 18 from both sides. And I get negative 27 equals b. So now I'm going to come back with all this information. I'm going to write my new equation in slope intercept form, and that would be my answer. All right, so the key on these kind of questions is you have to find your slope first by rearranging the formula to highlight the slope. Now there is a quick trick to this. Whenever you have if you're good with memorizing other extra rules and formulas, I don't really show this too often, but notice we move that x over and then we divide by the y. So the slope is actually going to always be whatever my coefficient of x is, negative, opposite of it, divided by b. So let's test that with this example, right? So the 6, if the equation was 6x minus 5y equals blah, 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 right? This means this is my ax plus by equals blah, blah, blah. So that means 6 is a and b is negative 5. My slope should be negative a over b, which is 6 over 5. So that's a shortcut that'll get you the right answer every time if all you're looking for is slope. If the task is to rewrite it into slope intercept form, then that doesn't help you, but hopefully that helps you a little bit. All right, so while I have this video going, I'm going to talk about perpendicular lines real quick. So perpendicular is when my lines cross at right angles. So the way this works is my slopes have to be opposite reciprocals. So if my slope of this line is negative 1 over 4, my new slope is going to be reciprocal. So I'm going to change it from 1/4 to 4, and it's going to be an opposite sign. So perpendicular lines have slopes that are opposite reciprocals. All right. And so now that we changed the slope, the problem is going to be similar to the other one. I'm going to say y equals mx plus b, or you can use point slope form. I'm not sure which one you like better. So this is my y, that's my x, 4 times 1 b. I don't know why everything is 3. So my new b is 3. Oops, that's my old slope. This is Ring Bros. So let's go ahead and actually confirm this, because I don't know if you at home remember Desmos, but it's a really good tool as you're checking your work. I have no problem with you using this on tests and quizzes to, as long as you can show me the work, you can use this to check your work. So the first line was negative 1 over 4x plus 11, I believe. Yep. And our new line was 4x plus 3. All right, and obviously I don't see my red line because it goes through 11, so it's kind of high. And they do intersect, so they're not parallel. And that does look like a 90-degree angle. I wonder where the geometry, there are geometry tools now. Or, you know what, that's like its own little thing. Never mind. But, feel free to go on here and explore with a whole bunch of other ones, right? So 4/3 would not be perpendicular. See how this is like a little bit like slanted now? It's not a 90-degree angle. But now if I change this to 3 over 4, now they become perpendicular. So, and again, notice that these Slopes are flipped fractions, so they're reciprocals, and they're opposite numbers. The only other one that's tricky is when you have a horizontal and vertical line, which we talked about a little bit, was so x equals a number gives you a vertical line, and y equals a number gives you a horizontal line because the slope is 0. So this is the only one that's like kind of a exception to that rule of opposite reciprocals, because the slope on this one is really 0, right? There's 0 x's, so that makes sense. And if you try to flip 0, it's going to say undefined. It's an error. And we know that an undefined slope gives us a vertical line. Right. So I hope this was helpful. If you need any more other examples, definitely reach out to me and let me know. I only did one because I didn't want to make this video too long. But if you need any other, I think really just the crux of it is to make sure that you can rewrite anything that's not y equals into that equation so that you can find the slope, and then you can go from there. Bye now.